Now we're going to go over naming transition metals, sorry. And we're going to name some transition metals. Now these are going to be different. That's why I want to do it in a completely different lecture. So you need to think of these as a different topic than main group metals. Okay? Remember main group metals, when we were looking at the name, we never really did anything with the subscript. Okay? But now we are. Okay, so naming a transition metal. Now what you do, just like you did on the other one, you're going to name the cation, okay, which is the metal, and then you're going to name the anion ending in "ide." Okay, so that part is the same. So you're going to have, sodium bromide. I mean, that's not this, but it's the same rules. The one rule that is different than the main group is that you need to put the charge in parentheses for your metal. Okay, so let's look at this example here. FeS. Okay. Fes. So what metal is this? This is iron. And then S will be sulfide. Okay, so far everything is exactly the same. Now here's the one difference here. We need to put the charge of iron in parentheses because iron can hold pretty much any charge, so you need to be able, just a shortcut, say what charge it is. So how do you know? Well, it's always going to take the opposite charge of your anion. So if we look on the periodic table, sulfur is right below oxygen. So it's in group 6, so it would have a 2- charge. So it has a 2-, so that means iron has a +2. It always takes the opposite charge. So what do I put in parentheses? Roman numeral 2. So this is iron 2 sulfide. Okay? So not hard. It's the same basic thing. We just need to put in parentheses what that other one is. So let's look at another one. Let's look at CuO. Okay, so how do I name this? So let's do the easy part first. Cu is copper. O is oxide. Remember, we need to end it in "ide." Okay, but now we need to put in our parentheses. So let's see what we put there. Oxygen is just like, is in the same group as sulfur, so oxygen has a 2-, so that means copper has a +2. Right? It's just the opposite charge. So this would be a Roman numeral 2. Alright? Not hard, easy enough. Let's do one more example. Let's do CrBr3. Okay? This Cr, if you look on the periodic table, is called chromium. Okay? And Br is going to be bromide. And I'm going to put this here so I don't forget to put the parentheses. Bromide. Okay? Now, this one is where a little bit trickier, just slightly. Okay? Bromine has a -1 charge because it's in group 7. Okay, but look here. This is a -1 charge, so you'd be, tempted to put a +1 right here. But look how many bromines we have. It took 3 of them, right, to neutralize the chromium. So if it took 3, and each of those 3 have a -1 charge, that means chromium was a +3. Okay? So in parentheses here, I put Roman numeral 3. So let me draw that out so you can see it. So this says I have 3 bromines, right? So let's put 3 bromines, -1, -1, -1. And then let me put my chromium over here. Now let's look at the the subscripts. Do you see right here, there's no subscript? So that's implied that it's 1. So I know for sure there's only one chromium because that's what it said. It doesn't have a 2 right here or a 4. It says 1. Okay? So I have, if I add up all of these charges here, -1 plus -1 plus -1, this equals to -3. So what charge does this need to have to neutralize a -3? A +3. Okay, so that's how I know chromium is a +3. Now let's look at this one here. Okay, I have 1 copper, 1 oxygen, because I have no subscripts here. So they both 1. I know oxygen is a -2. I only have 1 copper, so that means it has to be a +2. So just remember there's a little bit more math involved whenever you have a subscript, but it's not hard. Just multiply this out, the charge and the subscript. Whatever number you get, that is the number you're going to get for the charge for your metal. Okay? So how do I know when to use a Roman numeral and when not to use one? It's simple. You'll use a Roman numeral if it's part of the transition metals. So you see this sort of, well, it's blue, but more of a purple blue right in here. This whole block right here. These are your transition metals. Anytime it's any one of those, you're going to use a Roman numeral. If it's in group 1A, 2A, or 3A, you do not use a Roman numeral. Okay? So let's go backwards. So we have the formula, we can get the name, but let's see if we have the name, if we can get the formula. So let's use some of the same examples we did. Okay? So let's look at iron sulfide. Oh wait, we already, let's forget that I did that. Let's do a different one then. Okay, let's look at this one. Nope. Cu. Three. Oh. Or sorry, this is a 2. Let me just erase it. Okay. Copper 2. Okay, so what am I going to do? How do I do this? All I need to do. Ha! I will get this right eventually. So the only thing you will see here is CuO. I don't know why I'm writing the Roman numeral. Okay, let's start all over again. So how do I know what the name is? Okay, so let's rename the metal first. Copper. Okay, and let's name this here. This would be oxide. Okay, and then again, what Roman numeral do I have? This is a 2 minus, so this is a 2 plus, so that's copper 2 oxide. Okay, now going backwards. If I write down copper 2 oxide. Okay, how do I know what formula to write? Well, okay, let's write down the symbol for copper, Cu, and write down the symbol for oxygen. Okay, now the hardest part is figuring out the charges. On the periodic table, oxygen is in group 6, so that makes it a -2 charge. -2. But how do we know what charge copper is? You know, because I told you it could be any charge, really. We'll look at the Roman numeral. Roman numeral 2. So that tells us copper is a 2 plus. Okay, do you see that it'll take 1 copper to neutralize 1 oxygen because it's a +2 and -2. They cancel each other out automatically. So it's a CuO. And that's the formula. Okay, let's do another one. Let's do the chromium. Three bromide. So let's write down the simple part, which is just be the symbols. So you have Cr and Br. Okay? What charge does bromine have? Well, it's in group 7, so it'd be a -1. In chromium, again, we're going to look at this Roman numeral right here, so it's a 3, so it has a 3 plus. Okay, so chromium has a 3 plus, bromine has a -1. You see they won't neutralize each other right now. So how many bromines do I need? I'll need 3 to neutralize a 3 plus, or again, if you want to cross the charges down. So it'd be chromium, and then it's going to take 3 bromines. Okay, so Cr, Br3. Alright, let's look at one more. Let's look at the iron 2 sulfide. Iron is Fe, sulfide is S. Sulfur is right below oxygen on the periodic table, so it has a -2 charge. Iron, we look over here, Roman numeral 2, so it has a 2 plus. That is a 1-to-1 ratio, remember, because they both can be divided by 2. So that's just FeS. So the rules to figure out the formula are the same as the main group. Okay, now let's do the polyatomic. And these are going to be just the same as a monoatomic if you want, except now I'm going to use a polyatomic chart. Okay, so I'm going to name my metal, and then I'm going to have a Roman numeral plus my polyatomic ion. Okay, so let's write the name of this one. Oh wait, that was a main group. Let's not do that one. It's a main group. Here we do. Here's one. Let's try this. Iron 2 sulfate. So how do I know if it's a polyatomic or not a polyatomic? Remember, if it's not a polyatomic, it ends in "ide." If it is a polyatomic, it'll end in something else. 8, ites, whatever. But it won't end in "ide." Okay, so let's just write these down. I have iron, which is Fe. And what charge will that have? Again, you look at the Roman numeral, so there'll be a 2 plus. And sulfate, so if we look at our polyatomic chart here, sulfate is SO4 with a 2 minus. SO4, 2 minus. Okay, 1-to-1 ratio because they will neutralize each other automatically. So I only need 1 iron to neutralize 1 sulfate. So it just becomes FeSO4. See, it's the same rules as we just did. Okay, with the monoatomic, it's just now I have a polyatomic. So it just looks more difficult, but it's really the same. Let me see if I have another one here. Okay, let's look at copper. One nitrate. Copper is Cu, and the charge is +1. And again, I got that charge from the Roman numeral right there. Now let's look at nitrate on the polyatomic table here. Nitrate right here, NO2 with a -1. Okay, so that is going to be NO2 with a -1. Now do you see? These neutralize each other, +1, -1, so I don't have to do anything else. So CO or CuNO2, and that gives me copper nitride. And so hopefully that helps you. Let's go the opposite way. So let's see if we can figure out. So just kind of use what you know. Okay, so if I gave you FeSO4, okay, now let's look on here. We need to decide, is this a main group or a transition metal? Okay, so we look iron, Fe, it's found right here. So that's a transition metal, which means we need to use a Roman numeral. Okay, so I'm going to have iron, oops, iron, I'm going to have a Roman numeral, and then SO4, if we look on our chart, is sulfate. Now again, if we go to our chart, let's see what charge it has. It says sulfate as a 2 minus. Okay, so over here, sulfate 2 minus. So what charge does iron need to have to neutralize that? A plus 2. So I know this is going to be a iron 2 sulfate. Let's look at another one. We did this one. Cu and O2. This is going to be Cu is copper. This is a transition metal, so I'm going to use a parentheses. And NO2 is nitrite. Let's look this up to make sure. NO2 nitrite with a -1. So nitrite. And then we write over here, this has a -1. So what charge does copper need to neutralize that? +1. So this becomes copper 1 nitrite. Okay, let's do this. Let's do K2SO4. So potassium, is that a main group or is it a transition metal? If you look on your periodic table, it's in group 1, so that's a main group. So I'm going to just put potassium. Okay, now let's think. Do I need a parentheses? Nope, because it is a main group. So then SO4 is just sulfate. So potassium sulfate. So really what you're trying to decide between all of these examples is, will it have, in the name, will it have a parentheses or not? And again, a main group will not, but a transition metal will. Okay, now let me show you some additional examples you can do. So there's some, within the slides that you can do and try. But here it is. See, I'm on slide 39, it looks like. And if you click on there, it says good practice. That is a link. I already have this link pulled up. And this is what it gets you to. And all you have to do is you practice. And it's going to have a mix of main group and transition metals. And here it is. You can check. Write something. Obviously that's not right. And then show. So I did it wrong, right? So this should be 10 and then I2. Okay, so I did it wrong. So let's do another one. So then you go do the same thing. So CCM iodide, what should that be? And you write down the symbol and then your subscripts. So you can't figure it out. There you go. So you can check your answers and you can go to the next one. Anyway, you see, and here's like a transition. Anyway, but it's a good practice. I have no idea if you do it or not, but if you want to do it, you just, you don't want to do it in the homework because you get counted off. Here's just some additional practice. So again, this comes with practice, and memorization.